Hey, Ms. Smart here to go over your review for the Unit 3 Complex Numbers Assessment. All right, so let's get started. The first section is on addition, subtraction, and multiplication for complex numbers. So we have a value for F, for H, and for G. So for A, F plus H, F is 4 minus 3i, and H is negative 2 plus 6i, and we're adding. And so when you're adding with complex numbers, you're just matching up the real numbers. So 4 plus negative 2, that is 2. And negative 3i plus 6i is positive 3i. So 2 plus 3i. The next one, when you're subtracting F minus H. So there's a little more work when you're subtracting. Again, F is 4 minus 3i, and we're subtracting negative 2 plus 6i. So when we're subtracting, I always rewrite it without the parentheses, remembering that we distribute that negative to both of those. And so it's really 4 minus 3i plus 2 from the two negatives, and then minus 6i from the minus and the plus. Okay, but again, we're going to combine those real numbers. 4 plus 2 is 6, and then negative 3i and negative 6i all together make negative, so minus 9i. Now, as we're working through this video, isn't a lot of variation on answers. So if you think, oh, what I have is the same thing and I haven't talked about it, it probably isn't. And so you're going to want to make sure that you're getting all the way to the same answer as what I have, final answer. C, we're subtracting G, which is 7 plus I, minus H, which is negative 2 plus 6I. And so it's another subtraction problem. So I'm going to rewrite this without parentheses. 7 plus I stays the same, and then plus 2 and minus 6I. So the total of 7 and 2, 7 plus 2 is 9. Those are the real values. And then I minus 6I, it's like 5 minus 6, so negative 5. So 9 minus 5i. Okay, D and E are both multiplication problems. I recommend using the box to multiply. So F times H is the first one. I'm going to put F down the side, so that's 4 minus 3i. And H on the top, which is negative 2 plus 6i. Okay, so negative 2 times 4 is negative 8. Negative 2 times negative 3i is 6i. And the other column, 6i times 4 is 24i. 6i times negative 3i is negative 18i squared. Now, knowing that I squared is equal to negative 1, this is really negative 18 times negative 1, which is 18. So when we're getting the final answer, we want to combine the real numbers, negative 8 and 18. So they add up to 10. And then the imaginary number, 6i plus 24i is 30i. So 10 plus 30i. All right. E is H times G. I'm going to do it the same way. So h is -2 plus 6i, and g is 7 plus I. All right, so 7 times -2 is -14. 7 times 6i is 42i. Then I times -2 is -2i. I times 6i is 6i squared. So again, I've got this I squared here. I squared is equal to -1, so this bottom box equals -6. So the total of the real numbers, -14 plus -6, is equal to -20. And then the imaginary, 42i plus -2i, is positive 40i. All right. Okay, for f and g, we want to simplify those powers of I. So remember, if you were in my class, we made this diagram. We said this number line, this is the real number line, so 1 and -1. This is the imaginary, so I is up here and -I is down here. And we can use this to evaluate those powers of I, knowing that we start at 1 because I to the 0 is equal to 1. So every time we multiply by another I, we just move one place. So one strategy you could take for I to the 25th is to start here and count 25 times around the circle. It's not a strategy I would recommend, but you could. You could count 25 places and see where you land. But because it takes 4 to get all the way around the circle, I know like I to the 20th would land right here. I to the 24th would land right here. So I to the 25th would land up there at I. So that's the answer there. For I to the 46th, again, I to the 40th would be 10 full laps. So 40 would stop there. 41, 42, 43, 44, 45, 46 would land right there. So I to the 46th is equal to -1. All right. Now we're going to get into some quadratics. And so for number 2, how many real solutions does x squared plus 2x plus 15 equals 0 have? How many real solutions? And so remember, to find the number of real solutions, you just need to evaluate that part of the quadratic equation. So A is 1, B is 2, C is 15. So you have to find the answer to 2 squared minus 4 times 1 times 15. I'll give you a second to do that. Okay, here we go. You should have gotten -56. So since this is a negative answer, you're going to be evaluating and the square root of a negative number. So how many real solutions? There are no real solutions. However, there are 2 non-real solutions. because that's a negative number. Okay, number 3, select all the solutions. Well, I know I'm going to square root both sides here. So the square root of x minus 3 squared is x minus 3 equals the positive and negative square root of negative 25. Well, the square root of 25 is 5, so the square root of negative 25 is 5i. So that means x minus 3 equals positive and negative 5i. So we add the 3 over to get x by itself. And in the solution, the real number comes first. So 3 plus or minus 5i. So I'm looking for a 3 plus 5i, which I see right here, and a 3 minus 5i, which I see down here. Those are the only two. Okay, now we have some student work. They're solving the same equation. Nevaeh is solving by completing the square, and Lily is solving using the quadratic formula. So we have to finish Nevaeh's work and then write the solutions in that form, a plus bi. All right, so first she took the 25 away from both sides, figured out 16 was what completed the square, so then added that to both sides, and then wrote x squared, this is just the factored form of that, and negative 25 plus 16 is negative 9. So we are ready to square root both sides of the equation, which gives us x minus 4 equals the positive and negative square root of negative 9. And we can simplify that. Positive and negative 3, because that's the square root of 9, and then I is the square root of negative 1. So anytime there's a negative under your square root, there's an I in your answer. So we're almost there. We just need to add the 4 over. And since 4 is the real number, it comes first, plus or minus 3i. All right. So that's how you finish Nevaeh's work. And we'll go over here to Lily. And Lily is using the quadratic formula. So in this equation here, a is equal to 1, b is equal to negative 8, and c is equal to 25. So it looks like she plugged in a positive 8 here and a negative 8 here. So that's one problem. So this should be negative 8. This should be positive 8 altogether. And then I'm just going to kind of finish this part here. So negative 8 squared is 64, minus 100 is correct, and then that's negative 36. And then she has it over 2. Okay, so the next place where she made a mistake is going from here to here. So we already talked about how the 8 should be positive because it's negative 8. So that's one problem. But also, the square root of negative 36 is 6i. So she forgot to put the I right there. So we can do that over here. So x is equal to, and I'm going to break apart the division. So 8 divided by 2 plus or minus 6i divided by 2. All right, and so we're almost done. We just need to simplify those two fractions. So final answer, 8 divided by 2 is 4. 6i divided by 2 is 3i. So 4 plus or minus 3i And you'll notice that's the same as the other solution, which makes sense because they were solving the same equation. All right, so we've got just some quadratic equations here on the back side. We'll go through them one at a time. This first one here has the least amount of work because it's already in factored form and it's set equal to 0. So this means we're just multiplying. If you multiply two numbers and your answer is 0, then one of them had to equal 0. So either 10x minus 10 equals 0 or x plus 3 equals 0. So you solve those two equations. It would not be appropriate to multiply this out in a box and use the quadratic formula. It's way more work than you need. Just solve this. Add the 10 over, and you get 10x equals 10, and then divide by this 10 right here. X equals 1. That's one solution. The other one comes from the other factor. Take away the 3, x equals -3. So the solutions are x equals 1 and -3. Now for the rest of the equations back here, just to keep things consistent, I'm just going to use the quadratic formula. So keeping in mind that your equation has to be in this form in order for the quadratic formula to work. So I notice this is in the correct form. So A is equal to 1, B is -5, and C is -50. And so I'm going to evaluate B squared minus 4AC. And remember, when you put this in the calculator, that -5 must be in parentheses before you square it. Oops, let's do this. This needs to be a minus sign before the 4, not a negative sign. So 4 times 1 times -50. 225. So that's equal to 225. So I'm going to set up the rest of the quadratic formula. X equals -b. -5 is 5. The square root of 25, or the square root of 225, always check to see if it's a whole number. It is. So I'm going to write the square root of 225 first. And then just remember that actually equals 15. And then 2a, 2 times 1 is 2. So we have two values to find. 5 plus 15, right? That's the square root of 225 divided by 2, and 5 minus 15 divided by 2. So this one is 20 divided by 2 is 10. This is -10 divided by 2 is -5. So x equals -5 and 10. All right, we're ready for E. E is also in the proper form. So I know A is 1, B is 14, and C is -38. Okay, so first, B squared minus 4AC. So that's 14 squared minus 4 times 1 times -38. which is 348. And then I always just double check the square root of 348. Not a whole number, so I'm going to finish this one differently than I did this one, because here I got a whole number, so I evaluate all the way to single numerical values. Not a whole number, we address that differently. So x equals negative b, negative 14, plus or minus the square root of 348 divided by 2a. 2 times 1 is 2. Then we break it apart. Negative 14 divided by 2 plus or minus the square root of 348 divided by 2. Then we simplify as much as we can. Negative 14 divided by 2 is negative 7. And then since the square root of 348 isn't a whole number, it stays in the square root. And so we just say plus or minus the square root of 348 divided by 2. Be really careful with how you're writing your answers. They should honestly look exactly like mine. Exactly like mine. Okay, we're ready for the next one. Also already in the proper form. So A is 4, B is 8, C is 5. And so first find B squared, 8 squared, minus 4 times A times B. I have a feeling it's going to be a negative number because we haven't seen one of those yet. It's just a hunch, just a guess. 8 squared minus 4 times 4 times 5. Oh, look at that, negative 16. Negative 16. All right, so x equals negative b plus or minus the square root of negative 16 over 2a. 2 times 4 is 8. Okay? Now I know 16 is a perfect square. The square root of 16 is 4, which means the square root of negative 16 is 4i. So in our process of simplifying, we're going to break apart the division. And the square root of negative 16 is equal to 4i. So that's where the 4i comes from. And now just simplify as much as we can. So negative 8 divided by 8 is negative 1. And then plus or minus 4/8 is equal to 1/2. And I can just put the I there at the end. You could also have plus or minus I over 2. That would be the same thing. The negative 1 plus or minus I over 2, like this. That would be the same, an equally correct answer. Okay, E. I notice that E is not in the right form yet. So I have to start by moving this 12x, and I'm going to put it right in the middle since there isn't an x term up there. So 2x squared minus 12x plus 10 equals 0. So now that I've got it in the right form, I can state A, B, and C. A is 2, B is negative 12, and C is 10. Okay, so now we can find B squared minus 4 times A times C. And again, with that negative 12 there for B, make sure it's in parentheses. I got 64. So x equals negative b. So negative 12 is positive 12 plus or minus the square root of 64 over 2a. 2 times 2 is 4. Okay, now I do know the square root of 64 is 8. So rather than breaking up the fraction, this is a whole number, so you have to evaluate 12 plus 8, then divide the answer by 4, 12 minus 8, and then divide the answer by 4. So 12 plus 8 is 20. 20 divided by 4 is 5. 12 minus 8 is 4, and 4 divided by 4 is 1. So x equals 1 and 5. All right. This one is also not in the right format, so we'll start by adding the 20 over so that we get a 0 there. Again, there isn't a constant, so the 20 is just going to go at the end. And so in this equation, I'm going to use the quadratic formula. A is 1, B is 1, and C is 20. So I'll start by finding B squared. 1 squared minus 4 times 1 times 20. I think it's going to be negative. Okay, so 1 squared minus 4 times 1 times 20 is negative 79. And while I have the calculator, I'm just going to check positive 79. Oh, not a whole number. So I'm going to be using a square root in my answer and also an I because of the fact that this is negative. So x equals negative b, negative 1 plus or minus the square root of negative 79 over 2a. 2 times 1 is 2. So we're going to break this apart and simplify as much as possible. So negative 1 divided by 2. This will be root 79 I divided by 2. And then that's actually the final answer. I'm going to rewrite it here. X equals negative 1/2 plus or minus root 79 divided by 2 I. Your I can be at the end. It can actually even be before the square root. It can be in the top of the fraction. It just can't be under the square root. It has to be clearly on the outside. Okay, so that is the end of the solving quadratic equations. The last question has lots of possible answers. So this graph is the graph of f of x equals 3x squared minus 18x plus 15. And notice that's the same right here. Determine a value for m that would cause the equation to have 2 real solutions and then 2 non-real solutions. So any value that crosses the graph in 2 places that we can actually say right there and right there, that has 2 real solutions. I can graph them right there. So I chose 7. This is an example of what it looks like to have 2 real solutions. Okay, one thing that this question didn't ask us, but I'm going to talk about anyways, is how about 1 real solution? So 1 real solution looks like it would need to touch right there in 1 spot. I think this looks like negative 3. So this would be an example of one real solution if it was equal to -3. And then for two non-real solutions, it just has to be below -3. So I'm going to choose -5. It doesn't touch the parabola at all. So that's why it's two non-real solutions. We could figure out the imaginary or complex solutions, but we just know if this is equal to -5, they're not going to touch. And therefore, there's non-real solutions, two of them always. They always come in pairs. So A just has to be any number greater than -3. So A could be any number in that direction. Any value above -3 would give you two real solutions. And then for non-real, any value below -3. So you could have said like -100. It doesn't have to be on the graph, but just clearly below -3. All right, that's the end of the review. I hope you make a good note card and study really hard and do well on this test.